DevOps and CI-CD Part 14. This episode has 3 questions. For each question, take a moment to think through your own answer before I share a strong approach. Question 1. Explain image scanning. Here's a strong way to approach it. What is image scanning? Image scanning is the process of analyzing a container image to identify security vulnerabilities, CVEs, outdated packages, misconfigurations, exposed secrets, license compliance issues. It helps ensure that only secure images are deployed to environments such as Docker and Kubernetes. Why image scanning is important? A container image may contain application OS packages, libraries, dependencies, runtime. Even if your application code is secure, vulnerabilities can exist in base images, open source libraries, operating system packages. Example, from Ubuntu 20.04. The image may contain known vulnerabilities that need patching. How image scanning works. Container image scanner vulnerability database, CVEs. Security report. The scanner compares installed packages and libraries against vulnerability databases. Common vulnerability severity levels. Severity description: critical, immediate risk, exploit, available, high, serious vulnerability, medium, moderate impact, low, minor issue, and known, not yet classified. Popular image scanning tools: Trivi, Gripe, Claire, Snyk, Prisma Cloud. Example using Trivi: Scanon, image, Trivi image, Ginks. Latest sample output: total 12 vulnerabilities, critical 1 high, 4 medium, 5 LOW. 2. What does image scanning detect? OS package vulnerabilities, OpenSL, glib, curl, bash language dependencies, Python packages, Node.js modules, Java libraries, Go modules. Secrets. Examples: AWS keys, API tokens, passwords, misconfigurations. Examples: running as root, weak permissions, insecure settings, CI or CD integration. Typical pipeline: code commit, build, image scan, pass, yes, no, deploy, block, build. Example: Docker build, t-myapp, v1 Trivi image myapp, v1 fail pipeline. If critical vulnerabilities exist, security policy is violated. Best practices: checkmark, scan images during CI or CD, checkmark, use minimal base images, Alpine, Distroless, checkmark, keep base images updated, checkmark, regularly rescan stored images, checkmark, block deployment of critical vulnerabilities, checkmark, remove unused packages, checkmark, scan both OS and application dependencies. Interview answer: 7+ years experience. Image scanning is the process of analyzing container images for known security vulnerabilities, misconfigurations, exposed secrets, and compliance issues before deployment. The scanner compares operating system packages and application dependencies against vulnerability databases such as CVEs and generates a risk report. Tools like Trivi, Gripe, Snyk, and Prisma Cloud are commonly integrated into CI or CD pipelines to enforce security gates. Image scanning is a critical DevSecOps practice that helps reduce the attack surface and prevents vulnerable container images from reaching production environments. Nice. Let's continue. Question 2. What is Trivi? Here's a strong way to approach it. What is Trivi? Trivi is an open-source security scanner developed by Aqua Security. Trivi that scans container images, file systems, Git repositories, Kubernetes clusters, infrastructure as code, IAC, SBOMs, software bill of materials for vulnerabilities, misconfigurations, secrets, and license issues. Why is Trivi popular? Easy to install and use, fast scanning, supports multiple artifact types, integrates with CI or CD pipelines, works well with Docker and Kubernetes. Open source. What can Trivi scan? 1. Container images, Trivi image, Ginks. Latest scans: OS packages, application dependencies, known CVEs. 2. File systems, Trivi FS. Scans local directories and source code. 3. Git repositories, Trivi repo, https:// or GitHub or example or repo. 4. Kubernetes clusters, Trivi K8s cluster checks workloads and configurations. 5. Infrastructure as code scans: Terraform, Kubernetes, YAML, Docker files, Trivi config. Types of findings, vulnerabilities. Example: OpenSL, glib, curl, reported with severity, critical, high, medium, LOW. Secrets detection: finds, API keys, AWS credentials, tokens, passwords, misconfigurations. Examples: container running as root, privileged container, public S3 bucket. Example: scan Trivi image myapp, v1 sample output, total 8 vulnerabilities, critical 1 high, 3 medium, 2 LOW. 2 CI or CD integration pipeline flow: code commit, build, image, Trivi scan, pass, yes, no, deploy, block pipeline. Example: Trivi image, exit code 1, Severity critical. High MIAP. V1 pipeline fails if critical or high vulnerabilities are found. Trivi and Kubernetes scan cluster. Trivi K8s cluster check. RBAC issues. Privileged containers. Security misconfigurations. Vulnerable images. Benefits checkmark. Open source checkmark. Fast and lightweight checkmark. CI/CD friendly checkmark. Multi-target scanning checkmark. Vulnerability plus secret plus config scanning checkmark. Kubernetes support interview answer. 7+ years experience. Trivi is an open source security scanner developed by Aqua Security that identifies vulnerabilities, secrets, misconfigurations, and license issues across container images, Kubernetes clusters, source code repositories, and infrastructure as code artifacts. It integrates easily into CI/CD pipelines and supports scanning of both operating system packages and application dependencies. In DevSecOps environments, Trivi is commonly used as a security gate to prevent vulnerable container images and insecure configurations from being deployed to production. Great. Moving on. Question 3. Explain Docker Swarm. Here's a strong way to approach it. What is Docker Swarm? Docker Swarm is Docker's native container orchestration platform that allows you to manage and run containers across a cluster of multiple Docker hosts. It turns a group of Docker servers into a single logical cluster. Why Docker Swarm? Without Swarm, Server 1 containers, Server 2 containers, Server 3 containers, you manage each server separately. With Swarm, Docker Swarm cluster node 1, node 2, node 3, all nodes are managed as a single system. Swarm components. 1. Manager node responsible for cluster management, scheduling containers, maintaining desired state, handling API requests. 2. Worker node responsible for running application containers, executing tasks assigned by manager's architecture. Manager node. Worker node 1, worker node 2, create a swarm cluster, initialize swarm. Docker Swarm init output provides a join token. Join worker node. Docker Swarm join token